Hi and Assalamualaikum. Our group will make a presentation topic 2 that is about application of differentiation, mainly used in stationary point and rate of change. Our group member is me, Siti Raihana, with metric number of 1031, Nur Karina 1013, Nur Amira Farhana 1021, and Nur Aisha Fatiha 1041. Stationary points. Stationary point or critical point is a point at which the curve gradient is equal to 0. Consequently, if a curve have an equation of y equal to fx, that a stationary point will always have f prime x equal to 0, dy, which can also be written as dy over dx equal to 0. In other words, the derivative function equals to 0 at a stationary point. And we need to remember there's 3 types of stationary point. There is first maximum point, second one is minimum point, and the last one is point of inflection. Rate of change, there's 3 types of it. The first one is rate of change of volume, dV over dt. That is, unit used is centimeter cube over second. The second one is rate of change of area, dA over dt, centimeter square over second. And the last one is rate of change of radius, dr over dt, centimeter over second. We need to remember that if the value is positive, the quantity is increasing with time. And if negative, quantity is decreasing with time. Solve rate of change question is the first one. We need to write down the information given and what to find. The second one is create chain rule, and the last one, write equation related, differentiate it and find the answer. This is an example question that related with stationary point. Okay, the question is, find the stationary point of y equal to x cubed plus 3x squared minus 9x plus 1. We need to remember that the gradient is dy over dx. So a stationary point has a gradient dy over dx equal to 0. From the function given, y equal to x cubed plus 3x squared minus 9x plus 1, we need to use the famous rule to differentiate it. That is, bring power to the front and reducing the power by 1. Then we get dy over dx equal to 3x squared plus 6x minus 9. So we want 3x squared plus 6x minus 9 equal to 0. We need to divide both sides by 3 and we get x squared plus 2x minus 3 equal to 0. And then we get, we need to factorizing it to get the value of x. X plus 3 times x minus 1 equal to 0. Then we get x equal to negative 3 and x equal to 1. After we get the value of stationary point, we need to determine type of stationary point. Either it is maximum point or minimum point. Okay, like before, we have a stationary points of negative 3, 28 and 1, negative 4. Now, dy over dx is equal to 3x squared plus 6x minus 9. We need to use the second derivative order, that is d square y over dx squared. Now, dy over dx is equal to 3x squared plus 6x minus 9. We need to use second derivative order on that and we get 6x plus 6. We need to substitute the first stationary point, that is x equal to negative 3, and we get negative 12. Negative 12 is a negative value, so negative 3, 28 is a maximum point. Because negative 12 is smaller than 0, so it is a maximum point. Now, we need to substitute the second stationary point, that is x equal to 1. So d square y over dx square is equal to 12. Positive value, 12 is a positive value, so 1, negative 4 is a minimum point because it is larger than 0.
In this essence, we learn how to find stationary points. Stationary points are specific points on graph. This graph for minimum and maximum points. To find a stationary point, we need to find the coordinates where the gradient is 0. That is where dy dx equals 0. For example, let's find the stationary point of y equals x cubed plus 6x squared plus 9x plus 4. We said dy dx equals 0. And solve for x, dy dx equals 3x squared plus 12x plus 9. We said dy dx equals 0. We now solve for x. This is a quadratic, so we can solve it equal to 0 by factorizing. We can further divide each term by 3. We can factorize to get 0 equal x plus 1, x plus 3. This is since 1 and 3 add to make 4 and multiply to make 3. We solve this by finding the value of x that makes each bracket equal 0. We get x equal negative 1 and x equal negative 3. To find the y coordinate when x equals minus 1, we sub into the original function. This can be evaluated to get y equals 0. There is a stationary point at x equal negative 1, y equals 0. When x equals minus 3, we find the y coordinate by evaluating the function. When x equals minus 3, we evaluate this to get y equals 4. We have a second stationary point at x equal negative 3, y equal 4. Lastly, we have first and second point. Thank you.
Selected rate of change. Whenever we talk about rate of change, that's the change of something with respect to time. If we talk about the rate of change of x, that will be dx over dt. The rate of change of radius is dr over dt. Rate of change of an area is dA over dt, and the last one is rate of change of a volume. We can call that dx over dt. So here we got a question. The radius of circle is inscribed at a rate of 3 cm per second. So the rate of change of the radius, that the dr over dt equal to 3 cm. Find the rate of change of the circle area when r equal to 10 cm. So here we got the radius of a circle. So we got a circle with a radius. The rate of change of the area is dA over dt. So how are we going dA? We are going to use change rule. So we say dA over dt equal to dA over d something multiplicate d something over dt. We already know dA over dr and dr over dt. And dr cancelling out, leaving dA and dt. So we have 3 at dr over dt, and we do not have dA over dt. So we can use formula that link a and r. Do for circle a equal to pi r square. So we can find dA over dr by this formula. So dA over dr equal to 2 pi r. So we'll simplify that to 6 pi r. So when r equal to 10, dA over dA over dt equal to 6 pi times 10, and the answer is 65 centimeters square per second.
My name is Raisha Fatiha. My metric number is F1041. And right now, this is an example of how to find the rate of change. So figure show a circular cylindrical metal rod is expanding as it heated. After T seconds, the radius of the rod is x cm and the length of the rod is 5 x cm. The cross-sectional of the rod is increasing at a constant rate of 0.032 centimeters squared as negative 1. So the first question is to find dx per dt when the radius of the rod is 2 cm, giving your answer to 3 significant figures. So they already give us the rate of change equals to 0.032 centimeter square second negative 1 equals to pi x square. So dA per dx equals to 2 pi x, and then dx per dt dx per dA, we change it so 1 per 2 pi x. So after that we can start find our dx per dt when x equals to 0. So dx per dt equal dx per dt equals to dx per dA times dA per dt. So 1 per 2 pi x times 0.032 equals to 0.032 per 2 pi x when x equals to 2. dx per dt equals to 0.032 per 2 pi in brackets 2 because we change x into 2. So equals to 0.0255 centimeters second negative 1. The second question is to find the rate of increase of the volume of the rod when x equals to 2. V per dt equals to dv per dx times dx per dt. So first, let's find dx per dt first. So dx per dt equals to 0.032 per 2 pi at v equals to pi x squared times 5x. So v equals to 5 pi x. Then, or maybe we can turn it into 15 pi x squared. The next step is 15 pi x squared in bracket 0.0 per 2 pi x when x equals to 2 dv per dt equals to 15 pi in bracket 2 square in bracket 0.032 per 2 pi x. 2. So the final answer is 0.48 centimeters cubed second negative 1. That's all. Thank you.